sign convention for directions. Okay, so whatever you see right there in the board is a Cartesian plane. Okay, but instead of showing x and y, it's showing you directions. For example, when it goes up, it's gonna be considered to be north, south, down, east to the right, west to the left. But you can also see the signs that are gonna be considered for this kind of directions. And direction matters because when we talk about displacement, direction needs to be specified in the problems. So if I tell you a person walked, okay, if I tell you that a person walked 50 miles to the west, you can say that that person walked negative 50 miles. And this negative comes from the sign convention that the west, which is located to the left, has a negative sign. Okay? So every direction is going to have a sign. If I tell you that a person walked 120 kilometers north, is it going to be positive or is it going to be negative?
Positive.
Positive. 120 kilometers. And it's positive because it's going to the north. Okay? So those are directions that are considered to be positive and negative. It doesn't really mean that going somewhere is going to happen something bad or no. No, these are signed conventions for calculation purposes. So remember this sign convention. Now take a look to this example that I have over here. Okay? A person travels from City Mall to Launa.
Miss,
Yes?
and that's the same. You will send it to the presentation to the group and we have to copy it, everything.
Yes. You have to copy everything. What I care the most is that when I need to explain a topic, that you guys pay attention. If you're here just because it is mandatory to be here, this is pointless. Whether you copy it or not is going to be pointless because the general idea is that you guys in here in this moment you pay attention. Okay? So imagine that a person travels from City Mall to Launa. Okay? There are some things that you can also identify in this kind of sketches. Okay? For example, here I tell you what is the distance between City Mall and Una. Wait, it's not updating. I hate this.
Miss, buenas tardes.
Sí, buenas.
Le habla la mamá de Astrid Suazo.
Ujú.
Fíjese que he estado pendiente de la clase suya, la anterior y esta, y fíjese que se le escucha bien bajito, como que está lejos del micrófono.
Pero estoy bien, o sea, estoy cerca, tengo una computadora aquí cerca, realmente no sé qué estará pasando. Lo que voy a hacer es que voy a ir por mis auriculares, tal vez. Tal vez los auriculares captan mejor sonido.
Sí, porque fíjese que la verdad no se le escucha, no se le entiende nada a la clase, la verdad.
Ok, gracias.
Recording in progress.
Okay, let me see. Okay, now it's working. My tablet is also working. Okay, let's see. Let's work with one example of displacement. Okay. Um, a person travels from City Mall to Una. Calculate the distance traveled. calculate the displacement, okay? Distance travel and displacement. I want you guys to understand the difference between the two, okay? Distance refers to how much there is from one side to another. And displacement, it refers to what I showed you earlier, okay? To the direction that people take. So for example in here, from City Mall to Una, it says that there is a distance of 20 kilometers. So if a person travels from City Mall to Una, that person is going to travel a distance of 20 kilometers. I take that from the picture. Now when it says calculate the displacement, let's say that Una is located to the north, okay? So that displacement, do you think it's going to be positive or negative?
Positive.
Because it's
Positive.
going to the north, it's going to be positive. So actually this displacement from this person is going to be positive 20 kilometers, okay? Now, let's say that the morgue is located south, okay? And this person is going to travel from Una to the morgue. What is the distance traveled? 10 kilometers, okay? And if I talk to you about displacement, is that displacement going to be positive or negative?
Negative.
Negative. Negative. So with this, I want you guys to see the idea of distance. Distance, it refers just a number, okay? Just to a number, while displacement is going to take in consideration the direction that the object is moving, okay? Now it says, now the same person travels from Una to, well, that one I already did it. Now, if I ask you, what is the total distance that this person traveled from City Mall to the morgue? What is the total distance that that person traveled? To do that, you need to add the distance from City Mall to Una, and also the distance from Una to the morgue. So what is the distance that we have from City Mall and Una?
20 kilometers.
20 kilometers. Mhm. And the distance from Una to the morgue, it said it was 10 kilometers. So when we refer about the total distance, is all the distance that that person traveled from City Mall to the morgue in total. Kelly, your microphone. In total, it will be 30 kilometers. Now, in terms of displacement, this is in terms of distance, okay? Now, in terms of displacement, distance. In terms of displacement, if I have to add the total displacement, I'm gonna do this here, okay? The total displacement. Take a look. For the total displacement, you will consider again that displacement, when we talk about displacement, we're going to refer as delta, which is the Greek letter delta that expresses changes, and we're going to use x. Delta x represents displacement. Okay. Now, if I'm talking about the total displacement, I will consider the displacement from City Mall to Una, that it was the displacement was positive 20 kilometers, and also the displacement from Una to the morgue. Okay, from Una to the morgue we got negative 10 kilometers. So in here, what is the total displacement that we get? Since we have different sign numbers, plus 20 minus 10, we're going to subtract. Okay, it's gonna give us positive 10. Even though the person traveled 30 kilometers in total, that displacement was only 10 kilometers. Why? Because we are going to consider the signs from the sign conventions that I'm giving you right here. And this is important because, well, because there in the graphing paper, in the graphing of average velocity, you need to also consider the signs. So imagine that a person is right here. Let's call this person A. Okay, a person A is located in this point. This point is point 0. Okay, okay, so this person wants to travel to the point 1. Okay, what is going to be the displacement? 20 meters or plus 20 meters or negative 20 meters?
Plus 20 meters.
Plus 20 meters, because we're talking about displacement. Plus 20 meters. If this person wants to go to the point 2, and I tell you what is the distance, what would you say about distance? Is the distance 15 meters, plus 15 meters, or negative 15 meters?
Negative 15 meters.
When we talk about distance, we don't care about the sign. So the only one where we will consider the sign is going to be for displacement. When I talk about distance, I talk just about the number difference for that saying. So in this case, the distance is going to be just 15 meters. It doesn't matter if it's to the right, to the left, south, north, it doesn't really matter. So when it's about distance, you can see no signs are going to be included. Okay? When it's about distance. When it's about displacement, yes, you have to include the signs. Now, what about the displacement? If that person goes to the point 2, what is going to be the displacement? Is
That
it
will
going
be
to
negative
be
15
exactly? In that
meters.
case, will be negative 15 meters because displacements are going to consider the signs, the positions, okay? So for displacement, then yes, we're going to consider the sign, and we say negative 15 meters as a displacement. But the distance is going to be just 15, okay? But displacement will be negative 15. Now a person goes to the point 3. This point 3 is located at 10 meters. And I ask you, what is the displacement from the point A to the point
plus
3?
plus
Plus
10 meters.
10, plus 10. Just remember this. Do not forget, displacement is all about directions. Okay? To the point 3 is going to be plus 10 meters. If I talk about the distance, what is going to be the distance from A to number 3?
10 meters.
So that's what I want you to see. I want you to notice the, the difference between the two things. Now, it's going to be very, very different if I ask you, what is the displacement that a person does from position 1 to position 3?
10 meters.
Well, I gave you a formula for displacement in the video that I uploaded the other day. The formula for displacement is final position minus initial position. Okay? So, because here we're talking about from point 1 to point 3, we're going to consider those points only. Okay? So, we are moving specifically from 1 to 3. Okay? So, what is going to be my initial point? 1 or 3?
1.
My starting point, the point in which I will start walking. It is the position 1 in this case. And the position 3 is going to be my final position. So from 1 to 3, 1 is going to be my initial position and 3 is going to be my final position. That is important that you guys get to do this. We say X final. What is the final position?
10 meters.
10 meters. What is the initial position?
20 meters.
So what is my total displacement?
Negative 10 meters.
Negative 10 meters. What does this negative 10 mean? Where did the person walk? To the right or
He
to the
walked to
left?
the west.
Uh-huh. Walk to the left, which is west. The negative, in this case, means that the person walked to the west, which represents a negative direction. Sometimes you're not going to need to use the formula to get a displacement, but some other times, okay, like we did here, we used the formula because it was more difficult to understand the idea. The distance is pretty simple to get because I know that a distance between 10 and 20 is 10 meters. For distance, that answer is good, but for displacement is not. The reason why this number is negative is because the person was right there to the north, and when the person goes back, is actually moving south, and when a person is moving to the south, it's going to have a negative displacement. So direction in displacement matters. Do not forget. Okay. In this example, I used north and south. So actually this person was walking to the south, not west, by the way. I had to do this correction. In this case, I will consider the directions east and west. Now consider these points. A person is going to move. Why is it to the west? Okay.
No, yes, Miss,
Ah,
you read it correct.
I already did the correction. Yes. Why is to the west? Yeah, it was south in here. I thought it was west, but no, it was south. Now imagine this. I have here, I'm going to establish 2 points, okay? This is my point A. This is my point B. This is my point C. Okay, imagine that a person needs to walk from A to C. What is the distance from A to C? What is the distance? And then
10 meters.
10 meters.
okay, the distance is 10 meters. Remember, you're not going to write signs. You're not going to write signs in distance. I wrote distance again. Now, what is the displacement? From
Negative
A,
10 meters.
negative 10 meters. You can do it directly because in this case it's easy to see because you're coming from a point 0. But when you're coming from a point different than 0, you better apply the formula. Now, you can do it directly by saying negative 10 meters, or you can apply the formula. Displacement from A to B is final position, that is at C, minus initial position, that is at A. The final position at C is negative 10 meters because it is in the left side, it's in the west. This minus is from the formula and XA, that is 0 meters. So whether you do it with the formula or mentally, you can see that it gives us the same negative 10 meters. Now imagine that I'm going to analyze this displacement from C to A. I'm talking about the same 2 points. What is the distance? From C to A, what is the distance?
10 meters.
10 meters. What is the displacement?
Positive
Plus
10.
10.
Positive or negative?
Positive.
Positive.
Positive because it's moving from west to east. So this is the motion that it has. From C to A is moving to the east. If it goes to the east, everything that goes to the east will be considered positive. Everything that goes to the west or to the left is going to consider negative. In this case, the displacement is plus 10 meters. So you see, that's more or less the idea in general that I want you guys to work with. Now, okay. Now, this what you see over there, we have a Cartesian plane, okay? We have a Cartesian plane, wait. And this is more alike to the example that I explained you the other day. What are we going to have in this Cartesian plane? This is a graph, okay? This is a graph. Now, we're going to have two axes. As you can see, we're going to have two axes. The y-axis is the vertical axis. If it goes up or to the north, you will consider a positive sign. If it goes downward or to the south, you will consider a negative sign. In the y-axis, which is the vertical axis, what you are going to have is displacement, which is going to be measured in meters. In the x-axis, which is the horizontal axis, you are going to have a positive side of x when it goes to the right, and a negative side when it goes to the left. Basically the same idea that I told you before. Now, in this last part of the class, I want us to practice the last part that I explained you in the video. I'm going to call this my point A, B, C, and D. And we're going to talk about this slope. What kind of slope, positive, negative, or zero, I have from A to B? What kind of slope I have from
It's
A
positive.
to B? Remember what I told you in the video, okay? If it increases, it's going to have this shape. It's going to be positive. So a positive slope is important. I'm going to explain you why. Now, from B and C, what kind of slope I have over there? Positive, negative, or zero?
Zero.
Zero, okay? Zero. In this case, zero. We say that there is no slope. And from C to D, I have a positive, negative, or zero slope?
Negative.
Negative. So, we're going to consider the following equation. To calculate displacement, to calculate average velocity, you're going to need the formula for displacement and the formula for time. Here in the x-axis, you're going to have your formula for time that will be measured in seconds. Okay. So how do you read this graph? How do you interpret this graph? A person walks from position A to position B. Okay? The displacement was positive or negative?
Positive.
A positive displacement. Very good. Then, during B and C, 5 seconds happened. Okay? During 5 seconds, did the person move? Did this person move from position?
Yes, to 10.
That is the time. So during 5 seconds, that person didn't move. As you can see, the displacement doesn't show any change. When that happens, we have slope of 0 because there was no motion. So that person was in a certain point without moving. And then the person from the point C to the point D, what happened? What was the displacement? The displacement came from 10 to 0. This is the part of the graph that you have to see for displacement, the vertical axis. The vertical axis in this case is going to show you the displacement. So in this case, the displacement was a negative displacement because it's coming downwards. That's why the slope that you will get over there is going to be negative. Efrain, your question?
Miss, so we just consider displacement when it is positive or negative, right?
Yes, when there is no motion, displacement is 0, therefore the velocity is going to be 0 as well. I will continue this example in class